Today we're going to continue our work on finding fractions of amounts, and I've put some different activity sheets on Seesaw for you today, so I'm just going to go through a few examples as a reminder of how we do these, and perhaps just to have a look at some of the trickier questions that perhaps you're not familiar with. So if you are going to start the first section, let's have a look at a straightforward fraction. I'm going to find out 1/5 of 35. 1/5 of 35. And what we do here is we look at our amount, which is 35. We look at the denominator, which is fifths. I am splitting my 35. I'm dividing it into fifths, and that means into 5 groups. So I divide my 35 by 5, and I know from my times tables that 7 times 5 is 35. So there is 7 in each one. So 1/5 of 35 is 7. Okay, let me just draw this pie for you. Those should have crossed in the middle. And I'll shade in these now. If I'd have drawn this accurately, all of those sizes would have been equal. Okay, in challenge 1, you're going to get some questions like this. What fraction of that pie is actually shaded? Well, first of all, I need to know how many pieces I've got all together. And I'm just going to count them. I'm going to put a little marker on the outside so I don't count one twice or miscount. I know exactly what I've done. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pieces. How many are shaded? 1, 2, 3. So I've got 3 out of 8. So it's 3 out of 8. 8 all together, 3 shaded in. So that's 3 out of 8. Those are the kinds of questions you will be coming across if you do challenge 1. Let's have a look at challenge 2 for those of you who are going to start on challenge 2, or those of you that feel confident on challenge 1, you might want to move on to this one. Okay, here you've got some coffee cups, and they're divided up. And each one has got some coffee in it. So I'll just shade those in to show you that that is where it is full. And you've got questions which ask you what fraction of the coffee is left in the mug. Well, this is split into 4, and I've got 3 sections shaded in. So I've got 3 lots of 4. So 3/4 of that mug is shaded in. But there's a little bit extra to this kind of question. Let me say that this particular coffee mug holds 120 millilitres of liquid. And my question is, how much coffee is inside the mug? Well, I now know I've got 3/4, so I'm working out 3/4 of 120. Thinking about what we learnt yesterday, 120 millilitres is my amount. I'm dividing it into 4. So 4 into 120 goes 30. Now, but I've got 3 lots of 4. So dividing it by 4 gives me 1 lot of 4, but I want 3. So I take my 30 then, I times it by 3, and I get 90. So that particular cup has actually got 90 millilitres. And that's also a recap of how we find this kind of fraction of an amount as well. Those are the kinds of questions that you will come across on challenge 2. Let's have a look at challenge 3. For those of you who are going straight onto it, or those of you that feel confident with challenge 2 and you want to move on to this. Okay. Some people travel 48 kilometers. One person travels 5/6 of the distance. Another person travels 7/8 of the distance. Who's travelled the furthest? Well, we have to find out what these fractions are of 48. So first of all, let's find 5/6 of 48. And we know what we're doing now. We need to divide our quantity, the amount we've been given, by the denominator, the number of groups. So we do 6 into 48. And we know from our times tables that 6 times 8 is 48, and that's in sixths. But we've got 5 lots of 6. So we do 8 times 5. So this first person has travelled 40 kilometres. Okay, what about the next person? They've travelled 7/8. So I want 7/8 of 48. Again, I'm dividing by the denominator because I'm dividing into groups of 8. 48 divided by 8. Well, I know that there are 6 8s in 48. So dividing it into 8, every group has 6 in it. But I want 7 lots. So I want 7 lots of 6. So I multiply that by the 7, and that is 42 kilometres. And so now I know that the person who travelled 7/8 has travelled the furthest. Another type of question you'll come across is where you are given 2 fractions and you've got to say which one is the closest to a whole one. 6/7 or 5/6. Now we are not going to guess, we're going to work this out mathematically. Which one is closest to 100? Because both of them are only one off. But let's have a look. How are we going to decide? Well, the easiest thing for us to do is to make them both the same. If we turn them into equivalent fractions and see that they're both the same, it will be easier for us to tell which one is closest to a whole one. So, using my knowledge of fractions from before, I need a number that these 2 denominators will divide into. I wonder which times table, which answer we're going to get. What number will 7 and 6 both divide into? Well, using the times tables, if I just multiply them together, I get 42. I can turn them both into 42. What have I done to the 7 to turn it into 42? I times it by 6. So I've got to times the numerator by 6. And 6 times 6 is 36. So that one is 36 over 42. What did I do to this denominator to turn it into 42? I times it by 7. So I've got to times the top number by 7 as well, and that becomes 35. And now I can see very clearly, because they've both got the same denominator, they're both equivalent fractions, I can see now which one is closer to a whole one. Of course, in this case, the whole one, and I like to think of these as marks in a test or an assessment. If you got everything right, the number on the top is the same as the number on the bottom. So which one is closest to having that whole one? It is, of course, 36 over 42, which means 6/7 is closer to a whole one than 5/6. Have a go at those challenges. Read the questions carefully, work them out carefully. If you feel confident, you can go on to the next challenge up if you can.